Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome back to the subject geoinformatics, which has a code of GS 250. Topic for this week is global positioning system. We will cover the topic for this week, that is week 3rd, which will be global positioning system. It is our third lecture of the course. You can access to this course by using your login ID through portal.soot.edu.pk. Regarding any question, any query of this subject or this lecture, you can ask me a question or a query using my email ID, that is kamar.sewell@soot.edu.pk. So coming to the topic, which is global positioning system. We will just see the outlines of the topic which are given as what is a GPS. First we will cover GPS, the introduction of GPS, then we will see segments of GPS, that what are the segments of GPS, like what are the parts of GPS, and these parts of GPS and segments of GPS are space segment, control segment, and user segment. We will cover these 5 parts of this lecture. After these 5 parts, we will continue the lecture and cover the remaining parts that are how the system works, triangulation, distance measurement, accuracy, sources of error, and uses of GPS. These topics will be covered in the next week, and our main topic for this week, that is week 3rd, are these 5 topics or parts of the lecture, that is what is GPS, segments of GPS. These segments are space segment and control segment, and the last one is user segment. So coming towards one by one to these topics, that what is GPS. So the definition can be seen here, that a satellite-based navigation system which records and displays location of an object on the earth, that are X and Y coordinates, or in the other words, latitude and longitude. So let's see that what a GPS is. A GPS is a satellite-based navigation system which records and displays location of an object on the surface of the earth. For example, this is an earth, and we want to see that where something is located. So for this purpose, a constellation system is established, which are the satellites moving around the earth in a space. This is known as a constellation of satellites or constellation. In this constellation, GPS works like it records the object location and also shows the object location. For example, this is object A and it is located here. For example, we see that this is object A. This object has some latitude and longitude. Latitude are the lines which starts from the mid or the center of the earth towards north and south, while longitude are the lines which are from the two poles, starts from the first poles and ends at the second pole. This is known as North Pole, and the second one is known as South Pole. So these lines are known as longitude, while the other lines are known as latitude lines. If an object, that is object A, lies here, we want to see the location of this object. So how can we see the location of this object? This object can be traced by using a GPS. A GPS is a system, a satellite based system, which records, that is recorded the place of an object. For example, this object is lying here, object, so it is recorded. And also, with the help of this system, it can be displayed. For example, where someone is staying, where the object is located. So this object can be displayed, that the point or the object or anything that is lying here can be displayed. For example, if we see a Pakistan or an object which lies in Pakistan, like in Islamabad, we want to see a motor car where it is in Islamabad. So, for example, this is the point of a car which is located in Islamabad, and this located point is first stored in. This is stored in satellite satellite-based navigation system, which is GPS. Nowadays, everywhere we use GPS, like in motor car and other vehicles, as well as in mobile phones, etc. Much more applications of GPS are nowadays can be seen. So, coming towards the other point, that what is GPS? A constellation of Earth orbiting satellite maintained by the United States government for the purpose of defining geographic positions on and above the surface of the Earth. This statement says that the GPS is a constellation of Earth orbiting satellite maintained by the United States government, which is controlled by US government. For example, this is an Earth which is used for geographic position on or above the Earth surface. For example, if you want to see some body, some object or anything where it is located on the Earth surface. For example, this is the Earth surface. This is object A and it can be seen. So the US government used the satellite based system to see the point that where it is located. It might be on the Earth's surface or it can be above the Earth's surface. For example, this is above the Earth's surface. If you want to trace an aeroplane, so it is above the Earth's surface. So for this purpose, the American or the United States government used a constellation Earth orbiting satellites, which is known as GPS. So this is above Earth's surface and this is on Earth's surface. So GPS is used to see, to display, to store, to record the location of an object and to display the object position. And it can be measured, it can be done through the different satellites which moves around the Earth. So, GPS satellites are orbiting the Earth at an altitude of 12,550 miles. The altitude of GPS satellites from the Earth's surface is 1250 550 miles, mean 12,550 miles above the Earth's surface. This is an Earth's surface, and on the Earth's surface, the altitude of the satellite is 12,550 miles. So this is a huge and large length or height which can be seen from the Earth's surface. So this is why it covers a lot of area easily and can show the position of any object, or can be traced any object easily. Minimum 4 satellites are required for a GPS. This is like X or latitude, Y, longitude, Z, altitude, and T, time. So minimum 4 satellites are required for a GPS receiver, for a GPS device to track or to trace a device. Here we are going to see the segments of GPS. As everything, almost everything has some segments. So GPS has also 3 segments, and GPS works on 3 segments, which are necessary to be used. These are space segment, control segment, and user segment. First, we see that what is a space segment, that how space is related in GPS, that how space can be utilized for a GPS. Then we see that what is control segment, how control segment works, and in the last we will see the user segment of a GPS. So coming towards the first point of a GPS segment, which is space segment. So space segment consists of a dedicated satellites for GPS and referred as space vehicles. Space segment consists of a dedicated satellites for a GPS and referred as space vehicles. For example, this is an Earth, and above the Earth's surface, this is the whole area or the region is known as space. And in this space, different satellites are moving. For example, satellite 1, this is satellite 2, this is satellite 3, this is satellite 4, this is satellite 5, 6, 7, 8, 9, 10, etc. up to 24, and it can also be greater than 24. These satellites are known as space vehicles. These satellites are generally used to control the GPS. However, it's only a first segment. All the 3 segments are important for a GPS. If anyone is missing, then the GPS will not be completed, and we could not be able to retrieve our position or data, etc. from the GPS. So the space segment, for example, this is an Earth, and the all above area is known as, this area is known as space, and the constellation of satellites is known as space vehicles. The vehicles or the satellites which are used for the purpose of a GPS system is known as space vehicles or GPS satellites. There are 24 satellites in a nominal GPS constellation. Generally, there are 24 satellites for any GPS system. However, it can be greater than 24 satellites. These satellites remain in 6 orbit planes and are positioned such that 5 to 8 of these satellites are visible from any place on the Earth at a given point of time. This statement says that at least all the satellites which are revolving around the Earth are in 6 orbits. For example, we try it again. For example, this is an Earth, and this is orbit 1. This one is known as orbit 2. Like this is orbit 3, and this is orbit 4, and this is orbit 5. We are going to so this is orbit 6. These satellites remain in 6 orbital planes. If we see the GPS satellites or space vehicles, it must lie in these 6 orbital planes. That is, for example, plane 1, orbit 1, and this one is orbit 2, orbit 3, orbit 4, and orbit up to 6. So they are positioned such that 5 to 8 of these satellites visible from any place on the Earth's surface at a given point of a time. These satellites, for example, satellite 1, there is satellite 2, there is satellite 3, satellite 4, and satellite 5 to satellite 6. These are positioned so that it can easily be traced a position of a GPS device which is on the Earth's surface. I hope you understood this point. Coming towards the other slide, space segment consists of 24 plus satellites, 6 planes with 55 inclination. What does it mean? This statement says that there are 6 planes, orbital planes that I have discussed first. For example, this is orbit plane 1 or orbit 1. This one is orbit 2. This one is orbit 3, and so on up to 6. For example, last one is 6. I just want to say there that what does a 55 inclination mean? 55 degree inclination mean that this is plane 1, and the second one is plane 2, and this one is third. The inclination, if we see this part which is having some angle which is 55 degree, this one is 55 degree, the degree or the angle here will also be 55 degree, and so on up to 6 planes. There will be 55, 55 and 55 degree in each plane. Broadcasting position and time information on 2 frequencies. This is generally related to electronic parts. However, I want to say here that there are 2 frequencies used for position and time, like X megahertz and Y megahertz, but we are not concerned with this part because it's totally related to electronic point of view. It is important, however we are not doing in detail here. In the segment, a very high orbit, as we have discussed, that the distance from the Earth's surface to the satellites, which is known as altitude of the satellites, which is 12,550 miles. In kilometers, it will be 20,200 kilometers from the Earth's surface. One revolution in approximately 12 hours. It means that one revolution of a satellite completes in 12 hours. For example, this is the starting point and this is also the ending point of a satellite, which will take 12 hours. travel approximately up to 7,000 miles per hour. The speed of a satellite is 7,000 miles per hour. We are going to consider here accuracy, survivability, and coverage. These are generally considered for a GPS space segment satellites, where accuracy, survivability, and coverage all are seen. That is, the satellite is accurately giving us the location. Is the satellite survive more or cannot survive? And we also see the coverage, that can the satellite cover an area or not. So these points are under consideration where we want to see. There's a little bit general part. GPS satellites is also known as satellite vehicles or space vehicles. First GPS satellite launched in 1978. Full constellation achieved in 1994. Satellites built to last about 10 years, approximately 2,000 pounds and 17 feet across. In this statement is a little bit explanation, needs explanation, that the satellite, for example, this satellite, you consider first satellite, this its weight is 2,000 pounds and the length across is 17 feet. Transmitter power is only 5 or 50 watts or less. Transmitter power, like there's batteries and like there might be a solar panel system which is connected to some energy source, which may be battery, etc. So transmitter power is 50 watts or less than 50 watts. Coming to the second segment of GPS, which is control segment. The control segment consists of tracking stations located around all over the world. There are two parts, which is master control system and monitoring system. It can be seen from here. Master control system, for example, this one is master. It is located in different places. It's just an example here that two are given here, but it's not the real scenario. It can be like here. It can be like different parts of the earth on the globe. Master control station is we seen here that control segment consists of a master control system and monitoring control system. So these are master control system. It has directly related to the satellites which are moving here, like one, second one, third one, fourth one, etc. All over the globe. And master control can easily retrieve the data, and these can also be seen through monitor stations. Monitor stations are installed in different areas, and ground antenna is used to see the location of an object. Coming towards the last segment of the GPS, which is user segment. So what is user segment? In the user segment of a GPS is what we use, that is GPS receiver. The last one or the final part of the GPS system is GPS segment or the user segment. It consists of buttons for operation, antenna for signals receiving, and screen for display purpose. This one is a general GPS. It consists of buttons like these are buttons given here, button 1, 2, 3. That might be on off button, and it might be like a back button. It is for amino, and different button it might be. There is an antenna for signals, but here we do not see any antenna here. For signal receiving and screen for display purposes. This is a screen for display purposes. Signals from minimum 4 signals are required for a GPS receiver to complete to compute. As we have discussed that there are minimum 4 satellites required for any GPS user segment to trace or to track or to display the location of an object. That is satellite 1, satellite 2, and satellite 3, and satellite 4. Satellite 1 is X or latitude, satellite Y or longitude, and the third one is satellite third used for altitude, and the satellite fourth is used for time. So these are 3 segments. First one was control segment, the second one was first one was space segment, the second was control segment, and the third one is user segment. So these are the GPS segments. Hope you guys got this lecture. If you have any query about this lecture, and if you have any confusion in this lecture at any part, you can contact me on my email given at the first slide. Thank you for your patience.